Welcome to lesson 5.3 on more ratio type questions. For a warm-up, we're really going to quickly go over stuff with scaling factors. So question 1, if 64 is divided into 3 parts proportional to 2, 4, and 6, what would the smallest part be? So we have here a total. Oops, I can't spell today. A total, and we have here what the parts, the ratio of the parts. So we're going to use our scaling factor. And when it would normally be 2 to 4 to 6, I could also write that as 2k, 4k, and 6k. And we know that when we add all those 3 parts together, we're going to get 64. So collect like terms, and I get 12k equals 64. Divide both sides by 12, and that gives me 5.333333 repeating. When we go and we check what they were asking us, what would the smallest part be? That would be this one, the one that we used with 2k. So therefore, the smallest part would be 2k, which equals 2 times 5.3 repeating, or 10.6 repeating, or 10.67. The smallest part would be 10.67. Question 2. If 78 is divided into 3 parts which are proportional to 1, 1/3, and 1/6, find the middle part. So again, we have a total of 78, and we have our parts. They're in the ratios of 1, let's use blue, 1 to 1/3 to 1/6. So I could write that as 1k. Before we do this, maybe we should put them all, no, let's do this. So that'd be 1k or just k. That'd be k over 3 or 1k over 3. And k over 6, 1k over 6. And if we add all those 3 parts together, we know it gets 78. So now we have a question that has fractions in the denominator, but we learned a trick. We're going to find the LCD, the lowest common denominator, multiply everything by it. And since this one is over a ghosty 1, the lowest common denominator here is 6. So I'm going to multiply everything times, those brackets should be going down more, times 6. So everything times 6. And we'll cancel. So 1 goes into 6 just 6 times, 3 goes into 6 twice, 6 goes into 6 once, and we end up with 6k plus 2k plus 1k equals 78 times 6. So 78 times 6, so 468. So we get that, add up all the k's, 6 plus 2 plus 1 is 9k equals 468. So 468, divide both sides by 9. Divide by 9, and we get k equals 52. But we have to make sure we answer what was asked. And in this question, it said, find the middle part. And the middle part is this 1/3 or k over 3. So the middle part is k over 3, which is 52 over 3, which is 17.3 repeating. So that is our middle part. Question 3. On a map, the distance from Ms. Penna's home to Crescent is 15 centimeters. In reality, the distance from her home to Crescent is 10 kilometers. So first, we're going to find the scale of the map. So let's do that part first. So if we look at map versus reality, on the map, we have 2 pieces of information. On a map, it's 15 centimeters. So 15 centimeters. But in reality, that's 10 kilometers, right? In reality, is 10 kilometers. So the scale would be, for that first part, I'll call it like A. So the scale on the map would be 15 centimeters represents 10 kilometers. We could simplify it, divide both sides by 5, and we could get that 3 centimeters on our map is 2 kilometers in the real world. So we now have our scale. The second part says, on the same map, Crescent is 60 centimeters away from Miss Fioroni's home. So we now know, again, looking at, what was it asking? How far does Miss Fioroni live from Crescent? How far does Miss Fioroni live from Crescent? So this is a question about reality. In reality, how far is Miss Fioroni from Crescent? So if we look at map versus reality, we now know our scaling factor is 3 centimeters on a map equals 2 kilometers in the real world. If on the map it's 60 centimeters and we want to find out how far away she really is, we would call that x. We can cross multiply these. So we would get 3x equals 2 times 60. 3x equals 120. Divide both sides by 3. We get x equals 40. And on a map, things are measured in map, things were centimeters, but in reality, it's kilometers. So our answer is 40 kilometers. And our therefore final statement would be, therefore, Ms. Fioroni lives 40 kilometers from school. She lives way closer than that, but we just used it as her name since she's that other math teacher. Grade 4, a certain brand of fertilizer contains nitrogen, phosphorus, and potash in the ratio of 10 to 6 to 8. And then it says if the bag contains 2 kilograms of potash, how much of the others does it contain? So we're going to be looking at nitrogen to phosphorus to potash. And when we look at these three in ratio, we know that it's 10 to 6 to 8. That's what the question told us. But then it says that the bag of fertilizer contains 2 kilograms of potash. So in our question, we have 2 kilograms of potash. So in our scaling, from get to 8 to 2, we would have divided by 4, or we could have said that we multiplied by 0.25, same difference. So then to find out how much of the other ones we're going to need, so phosphorus would be 6 divided by 4, which happens to equal 1.5 kilograms. And then nitrogen would be 10 divided by 4, which is 2.5 kilograms. So our final answer would be, therefore, it contains 2.5 kilograms of nitrogen and 1.5 kilograms of phosphorus. B says, if another bag contains 18 kilograms of fertilizer, how much of each component does it have? So we had from before that we know nitrogen, phosphorus, and potash are in this ratio. But in this question here, this 18 kilograms is a total. So if we're given the total and we have the parts, we're going to use that scaling factor. So I could write that as 10K, 6K, and 8K. But we know that all together, when we add these parts, we get 18 kilograms. So 10K plus 6K plus 8K gives us 24K. So 24K equals 18. Divide both sides by 24. And that gives me a K. K equals 0.75. So they want to know how much of each component. We're going to go back to the beginning. So nitrogen is going to be 10K, which is going to be 10 times 7.5, or, times 0.75, 0.75, which is 7.5 kilograms. So that's how much nitrogen. The phosphorus is going to be 6K, or 6 times 0.75, which is 4.5 kilograms. And then the potash is going to be 8K, or 8 times 0.75, works out to be 6 kilograms. And we can check and see if we got it correct by adding these up. So if we were to add 7.5 plus 4.5 plus 6K, it does add up to 18 kilograms. So a way for us to see that we got it correct. Question 5. The sum of three numbers is 98. The ratio of the first to the second is 2 to 3, and then the ratio of the second to the third is 5 to 8. Okay, so that sounds pretty complicated. Maybe I'm going to write this out. So first to second to third. So the first to the second is 2 to 3. But then they also say, we got that from here, first to second is 2 to 3. But then they also say second to third is 5 to 8. So second to third is 5 to 8. And the way I think about this one is we need to find some way of being able to compare all of these. And one way to do it would be if we made the numbers here in the middle. If these numbers were the same, then we'd be able to have one big continuous long ratio of all three of them. So one way to make them the same would be to say, okay, what do we get if we multiply these two numbers? And that number would be 15. To get 3 to 15, I'd have to times it by 5. So then I'd have to multiply the first part of my ratio by 5. So that would give me a 10 there. And to get from 5 to 15, I multiplied by 3. And if I do it to that first part, I'd have to do it to the second part. And that would give me 24. So now we have one big ratio comparing the first to the second to the third. And if we have those ratios and we're given a total, remember this number here is a total. So if it's 10 to 15 to 24, I could write that as 10K to 15K to 24. And when I add up all those parts, it equals 98. So 10K plus 15K plus 24K gives us 49K. Divide both sides by 49. And we get that our scaling factor in this question is 2. But if we want to answer what was asked, it asked us to find, I don't need to write it out again, sorry. Find the second number. So if we're going to figure out the second number was this, right? That's how we represented our second number. The second number was 15K. So therefore, the second number is 15K, which is 15 times 2, which is 30. And that'd be our answer. For the next part, ratio of sides and ratio of areas. We talked about it a bit in the last lesson. If we have squares with side lengths of 2 and 3, the ratio of their sides would be 2 to 3. But if we're looking at their areas, 2 times 2 gives me 4 meters squared for that one. 3 times 3 would give me 9 meters squared. The ratio of the areas would be 4 to 9. And so if we're going from sides to areas, we're going to square it, 2 squared, and then 3 squared. If we wanted to go backwards, we could square root it. So if we had to go from areas to sides, we could square root the 9 or square root the 4, and both would give us the sides. It comes down to this rule. So highlight this, put something in your notes. It's really important that you know that the ratio of areas of two similar figures is equal to the square of the ratio of the sides. So the areas is equal to, the ratio of the areas is equals to the square of the ratio of the sides. Question 6. In art class, you paint a portrait of your favorite teacher. So here's a portrait of your favorite teacher, and you decide you love the painting and want to increase the dimensions of the canvas and paint a larger portrait. So if we make this a larger portrait, the larger painting is similar to the small painting with a side ratio of 5 to 17. So the ratio of the sides, is going to be 5 to 17. It then says, if it took 575 mils of paint for the small one, as soon as you see them talking about paint, this is really talking about surface area or focusing on that word area. So when it's talking about paint, it's really talking about surface area. So if we know the ratio of the sides is 5 to 17, then we know the ratio of the areas is going to be 5 squared and 17 squared. So 25 to 17 squared is 289. So if we're looking at small to big, our ratio is 25 to 289. And they told us the paint for the small was going to be 575, and they want us to find out how much paint for the big one. So I'm going to let X be how much paint we need for the larger one. I'm going to cross multiply these. So 25X and then 575 times 289. So here I get 25x equals 166175. Divide both sides by 25. And I calculate that it's 6647 milliliters. Because the paint was measured in milliliters, so this is going to be in milliliters. And we answer with a therefore statement. Therefore, we need 6647 moles of paint for the larger one. We're going to use the same thing with the ratios to look at another question about painting on statues. So 1 liter of paint is needed to paint a statue 3 meters high. Find the number of liters it will take to paint to the same thickness 540 statues similar to the original, but these ones are only 1 meter high. So we've got our big statue, which is 3 meters tall, but then we have a whole bunch of little statues that are only 1 meter tall, right? So we know it's 1 liter of paint for the big, X liters, that's what we're going to try and find for the small. So if we're looking at small over big, we've got the height, right? So the height is like this side. The ratio of the sides is going to be small is 1 and big is 3. So then the ratio of the areas is going to be 1 squared and also 3 squared. So the ratio of the areas is going to be 1 over 9. So then if we look at the ratio of paint, for the small one, we don't know how much paint it's going to need, but for the big one, we know that it was 1 liter. And we're going to use this and relate it to the amount of area, because paint, remember, deals with surface area. So we're going to build our equation from this, keeping in mind stuff about, so it's not going to quite be equals because we have 540 small statues, but we can figure out how much paint it would take for one small statue and just multiply it by 540. So from my proportion that I've created, I will cross multiply. And so I get 9x equals 1 times 1, which is just 1. So x equals 1/9. You could do it to a decimal. That'd be 0.1 repeating, or you could just leave it as a fraction. So then 540 small statues is going to equal 540 times 1/9. And when you do that calculation, you get that that's going to be 60. And paint was being measured in liters. So that would have been 0.1 liters. So 60 liters of paint. So therefore, 540 small statues needs 60 liters paint total. Question 8. Happy Camper Store sells tents in 2 different sizes. Put a big star beside this question. In 2 different sizes, large and small. Last year, the company sold 400 tents, of which 3/8 were large. Okay, so that's going to be important. Also that we are dealing with large and small. The ratio of the proceeds. Proceeds is a word that means the total from sales. So proceeds means the total from sales. So the ratio of the proceeds from large to small is 9 to 10. So proceeds, that's like your total, right? That's why I've done a number value total chart. Proceeds of large to small is 9 to 10. And then it straight up tells us what a large tent costs, and they want us to find out what a small tent costs. So I'm doing number value total, and I'm going to have small tents, not tent, and then large tent. We're trying to find the value of the small tent. The large tent, it told us cost $60. The number of them, up here it gave us that information. So 400 tents, of which 3/8 were large. So large is going to be 3/8 of, and of means times. So 3/8 times 400. So then that works out to be 150. So we have 150 large tents. And if we had 400 in total, that means small is going to equal 400 minus 150, which is 250. So we have number times value equals total. That's going to give me 250x for the small, 60 times 150 for the large. And I'm actually going to calculate what 60 times 150 is now. That equals 9,000. And then it tells us something about those totals. It told us that the ratio of large to small, so large first. Large comes first, so large is the 9. It's going to be in the ratio of 9, and then small came second. So this is what their ratio is. So we've got the ratio of small to large is going to be 10 to 9 in terms of their totals. And we're going to build our equation from this. So I'm going to write down that small over large equals 250x over 9,000. But we know that equals 10 over 9. If we cross multiply, we get 9 times 250x equals 90,000. 9 times 250 gives us 2250. Divide both sides by 2250. And when we do that calculation, we get that x equals 40. And looking back, x, I'm going to highlight in pink highlighter, x was this part here. X was the value in dollars. So x down here needs to be in dollars, and therefore the small tent cost $40. It's frozen again. For question 9. Today, the ratio between a boy's age and his father is 1 to 7. So boy to father is 1 to 7. In 5 years, the ratio of their ages will be 3 to 11. What is the father's age now? So we're going to use a now and then, with the then being in 5 years. In 5 years means we're going to be adding 5 to whatever we write down for now. So we're going to have boy, and we're going to have father. And boy to father is 1 to 7, but there's a hint here, let K be the boy's age. That's like if we did a scaling factor right here. So 1 to 7 would be 1K to 7K. So if the boy is K, then the dad is going to be 7K. In 5 years, it's going to be K plus 5 and 7K plus 5. And in 5 years, the ratio of boy to father, ratio of their ages will be 3 to 11. And we're going to build our formula from this. So we're going to write K plus 5 over 7K plus 5 equals 3 over 11. Cross multiply gives 11 times K plus 5 equals 3 times 7K plus 5 because we cross multiplied. So distribute the 11 gives 11K plus 55 equals 3 onto 7K is 21K, 3 onto 5 plus 15. I'm going to bring the plus 55 over to that side and the 21K over to this side. So 11K minus 21K is going to equal 15 minus 55. 15 minus 55 is minus 40. 11K minus 21K is minus 10. So divide both sides by minus 10, and we get that K equals 4. So that's our scaling factor. Let's go back and see what they asked us. What is the father's age now? So it asked, what is the father's age now? So the father's age now is going to be 7K. The father's age now is going to be 7K. So, therefore, the father's age now is 7K, which equals 7 times 4, which is 28. And then units would be years old. And that is it for this lesson. Thanks for watching.